students, welcome back to your mathematics class. Hope you all are doing well. In our previous lectures, I have explained you all exercise 1.1, exercise 1.2 of number system as well as their solutions also. So in this class, I'm going to explain you all exercise 1.3 of number system. This whole exercise is based on real numbers. So the question arises, what is a real number? Real numbers are the group of numbers which includes both the rational numbers as well as irrational numbers. Okay? So as you are seeing this chart, I've made this chart for your convenience. Please note it down in your rough copies or whatever the copies in which you are maintaining the notes, because it will be very helpful for you all. So real numbers can be distinguished with decimals and without decimals. All these without decimals are the part of rational numbers, which I have told you earlier in while solving exercise 1.1. I have explained you there that this set of positive number will be the natural numbers. Now from 0 to positive numbers will be the whole numbers. Now negative numbers plus 0 plus positive numbers will be what? Integers. And all these numbers comes under the category of rational numbers. Now let's move further with decimals. Rational numbers can be written in the form of what? P upon Q. So suppose it was 5 by 2. So this will be what? Terminating number. The answer will be, you must be knowing 2.5. So that will be terminating. So the foremost category is terminating one, where the remainder comes out to be 0. Now the second category is not terminating. Non-terminating means the remainder will never be a 0, but the figures after the decimal will be repeating themselves. Look over here, it's written 1.77777. We can write it as 1.7 bar because 7 is repeating itself. Over here 0.777, it is repeating itself, so we can write it as 1.7 bar. Over here you are seeing that the example says 0.363636. Always remember one thing, that after the decimal you are not going to pronounce the number as 0.363636. It is absolutely wrong. You have to pronounce it like that, single digit at a time after decimal. So you will be pronouncing it as 0.363636. So you will be seeing that 36 is repeating itself. So we can write it as 36 bar because 36 is repeating itself. So after 6, what will be the next digit? 3. Then 6. Then 3. Then 6. Okay. Till here, all these numbers which I have discussed till now are the rational numbers. Rational numbers can be without decimals and with decimals also. So now let's move towards the irrational number. In our previous exercise in 1.2, I have explained you the irrational numbers. So irrational numbers are what? Non-terminating as well as non-repeating. Like pi. Pi की value हम लोग you will be saying कि pi कितना होता है 22/7. तो मैम ये तो rational number हो जाएगा. No, it is the approximate value of pi. Pi value will be हमें always if you divide it 22/7, you will be getting 3.14 dash. It's keep on coming and it is not repeating. Okay, so non-terminating and non-repeating are the irrational numbers. All these numbers come under the category of real numbers. Okay. So the next topic of this exercise is real numbers and their decimal expansion. Means when we transform P upon Q into decimal numbers. So we have taken some rational numbers, 10 upon 3, 7 by 8, 1 by 7. Okay. So when we divide 10 upon 3, we will get 1 as a remainder and 3 point something 3.33333 and goes on the infinity as the question. In the same way, when we solve 7 by 8, तो 7 by 8 है तो 7 जा नहीं सकता, then we will put a decimal. After that 0 keeps on coming in, then we solve it, we will get 0.875. Over here, when we solve 1 by 7, we will keep on doing it and we got a remainder. Here the remainder as 1, while all these numbers will be the quotient. Okay. Here the remainder is 0 and the quotient is 0.875. Now, if you look at the pattern over here, you will be seeing that when we divide 10 by 3, we will be getting, after decimal, we will be getting a same number, that is a repeating number 3. 3, 3, 3, 3, 3. So, we will be terming this section as non-terminating repeating rational number. Okay. Now, what is this? Here, the answer is, remainder is 0. We got a question. So, this is a terminating example. While when we divide 1 by 7, we keep on doing it. We got a question 142,875. Okay. Now the remainder again came out to be 1. Now the whole process start again because the divisor or the dividend has repeated itself over here again. Now 1 again has come. Now the whole process repeat itself. So this is repeating itself again. Okay. So this is what? This is also an example which is same as non-terminating as well as repeating. Because here the remainder came out to be 1. So this is also the same example, non-terminating as well as repeating. So when a question repeat itself, we can write it down as 3.3 bar. Okay, which I have already discussed it with you in our previous slide. So 3 is repeating itself. So we have written it 3.3 bar. After decimal it's repeating. That's why I have put the bar after the decimal. Now here the quotient is not repeating as well as it's a terminating example. So we will simply write it down. 7 by 8 is equals to 0.875. Okay. Now here the question start repeating itself after 7. Now the whole of this will start repeating. When we solve it further, then again we got 1, 4, 2, 8, 5, 7, 1. Then again we will get 4, 2 and keeps on. So this process will keep on repeating itself. So the numbers start repeating itself after 7. Now we are going to put the bar till 7. From 1 till 7. So the answer of this expansion will be 142,857 bar. Now this bar is termed to be as string. What? We term them as string. So here the string consists of how many numbers? One number. Now this bar consider as a string, and string consists of how many numbers? One number. And here this bar have a string of how many numbers? Let's calculate. 1, 2, 3, 4, 5 and 6. Always remember one thing, that the divisor is always greater than the string. Over here, what is the divisor? This is the divisor. So what is the number of divisors? 7. And the string will be always less than what? The divisor. So 7 is greater than 6. So this is what I am saying. And over here you can also see 3 is the divisor, and the divisor 3 is greater than 1. So remember one thing, this thing, that the divisor is always greater than the number of string. Okay. There are few points which you have to remember while calculating the decimal expansion. Is that number 1, remainder becomes 0 or remainder itself after certain stage. Remainder will become 0 or it will repeat after certain stage. Here you are seeing it's repeating, and here you will see that it after a stage, after this expansion, it starts repeating itself. So the first point to remember is that remainder becomes 0, or here the remainder equals to 0, or it starts repeating itself after certain stage, or start repeating. The number of entries in the repeating string of remainder is less than the divisor. This is what I told you afterwards. That the number of entries, these are termed to be the entries. The number of entries in the string will be lesser than the divisor. And the next point to remember, that if the remainder repeat, then we get a repeating block of digits in the question. If the remainder repeat itself, then we get a repeating block of digits in the question. Look over here. It's a repeating block of digits in the question. Over here also, remainder. When the remainder repeat itself, we get a repeating block of digits. Okay, got it this much? So till here we can easily conclude the two cases, that number 1, that remainder will become equal to 0, like in this case. In the second case, the remainder came out to be 0. And the second point to remember is that the remainder will never become 0, like in the first case and the third case. We are getting remainder which is not equal to 0. Remainder does not equal to 0. So there are two major cases why we calculate, convert a rational number into a decimal number, a P upon Q into a decimal number. Okay? Now we have learned to convert a P upon Q into a decimal number. Now, but can we change or convert a decimal number into a P upon Q number? Suppose, can we convert 0.875 into P upon Q. How can this will going to be happen? This is our next topic. So let's get started with that. So let's take an example. Express 0.666666 and goes on into P upon Q. So how could we do that? Let's solution. Let at x is equals to 0.66666. Okay. So when we multiply, we are going to multiply 10 in both, multiply 10 in both sides. Okay. Then we get 10x is equals to what? 6.6666. Okay. Now what will happen now? 10x can be written as 6 plus 0.66666. Can we write 6 as 6.66666 as 6 plus 0.06666 so that we could get the value of x from here? Okay, we can get the value of x over here. This number is equals to what? X only. So we can write it down. X is equals to 6 plus x. 10x is equals to 6 plus x. Got it this much? Now 10x, we will moving x towards the left hand side. So we will be getting 9x is equals to 6. Therefore x is equals to what? 6 upon 9. And we are going to reduce in lowest terms. So we will be getting 2 by 3. This is what? Our answer. And this is how we are able to convert a decimal into a fraction. Got it till now? Let's take another example. Convert 3.14268 into P upon Q. If you look over here, it's a simple thing. You must be doing 4.2 can be converted as 42 upon 10. Right? In the same way, we can convert this 3.14268 upon, because this is not this is a terminating number. Look over here, this is a terminating number, while the earlier example was a non-terminating number. So we have to follow that process. But here we are looking that it's a terminating number, so we can easily convert, divided by the after the decimal, how many digits we are having? 1, 2, 3, 4, 5, 6. 6 digits we are having. So we will be dividing it by like this. 1, 2, 3, 4, 5, 6. Okay. This would be our answer. Okay. Now let's move and take another example. Now here we have to express 2.373737, or we can say 2.37 bar into P upon Q. So How could this will be happen? Let here one more thing which we have to remember, that the string is consists of how many numbers? Two numbers. Here the string consists of how many numbers? Two numbers. So we are going to multiply it by how many? By not by 10 over here. We are going to multiply our this number with 100. If we are having 2, then we will multiply it by 100. If we are having 1, then we will multiply with 1 or 10. If we are having the string of 3 numbers, then we are going to multiply it by 1000. Remember this one thing in your head. Okay. So let's get started with this. So we are multiplying this string. Let's take 100x is equals to, what will be the answer? 237.3733737 and goes on. Okay. Now 100 as x is equals to what? This thing. And we have considered that x is equals to and we have marked this whole thing is equals to what? X. So we are going to multiply it by 100 on both the sides. Therefore 100x is equals to what? 237.373737. Okay. Now we have to calculate this value. Okay. So what number should be subtracted from this so that we can easily get x over here? So 235 can be written as plus 2.3737. This is what? Our value of x. So 100x is equals to 235 plus 2.373737. And this is what? Our x. Okay. Now x will come over here. Common factors, terms, minus x is equals to 235. Therefore, x is equals to what? 235 upon 99. This is our answer. Hope you got this much. Let's take one more example. In case of any confusion, you are free to call me up during this and you can easily ask me questions. Now let's take another example. The question says express 0.2353535 into P upon Q. Okay. Pen is not working. Yeah. So here, look at the string. String is saying 0.235 bar. As we are repeating, the string is repeating itself but after one digit. So we first take out this string over here because this value is repeating. 2 is not repeating itself. So we have to take it further. So we can say x is equals to 0.235 bar. Okay. Now we multiply 10 in to both sides. Okay. So when we multiply it 10x, why we are doing it so? Because we want a proper string after the decimal. But 2 is not creating it to be a proper string. So we have to take it out. So we are multiplying it by 10. If it was written 0.21353535. Then we will be multiplying it by 100. Okay, but here only one digit is there. So to take it for outside that decimal point, we are multiplying it by 100. So the value will become like this. Now let's take this string. What is the string? The old formula. How many numbers are there? Two numbers. So we will be multiplying it by what number? 100 on both the sides. So we will be getting what? 1000 x is equals to 235.3535 and it goes on. Okay. Now we know that 2.35 is equals to 10x, and here above we can't calculate x value over here. We can get the value of 2.35. So by what number, how many numbers should be added to 2.35 to get this figure? So we will be subtracting 235 by this. So the value which we get is 233 plus 2.3535. So 1000x will be equal to this. Okay. Now what is the value of 2.353535? 10x. So we can write it down. 1000x is equals to 233 plus 10x. Okay. Now like terms together. So 1000x minus 10x is equals to 233. Now 990x is equals to what? 233. Okay. Now we will get the value of x is equals to 233 divided by 990. Okay. This is our answer. Hope you have gone through each and every example thoroughly. Please go through that and solve this exercise. So we will meet again later soon with our next exercise. Till then, stay safe at your home and do your work thoroughly.